So number 9b, to find the molality. And we know that molality is equals to mole of solute all over kilogram of solvent. So anytime you're dealing with molality, I told you to always make sure that whatever you're doing is in kilogram. So first of all, mole of HCl is given to be 11.8 all over kilogram of solvent. Remember that this HCl is in liquid form, and we have water. That is, we don't know if it's water, but they gave us something of density, so there's a solution there. So we simply need to get the kilogram of the two solvents, then subtract from each other so that we get the actual solvents. So I'll get to get the kilogram of water. We've already gotten it actually, if you remember. So to get the kilogram of water, that is of the solution, is simply getting your answer in kilogram per liter. So making sure that your answer is in kilogram per liter. And how did we do it? We did the gram given to us divided by 1000. So it's essentially saying divide gram by 1000, then divide milliliter by 1000 to get to liter. So it should be in kilogram per liter. So that is for it. So that means that what we are looking for now is, what we are going to be looking for, the kilogram we are looking for now is the kilogram of HCl. So kilogram kg of HCl. And we know that HCl, the mass of HCl is equals to okay, let's check. I think we've gotten it too. Mass of HCl, the mass of HCl is 430.228 gram. Okay, but we need it in kilogram. So all we just need to do is to divide this answer, this value, by 1000. So we already got it. That is by doing mole times molar mass. So 430.228, that is in gram, divided by 1000. We need everything to be in kilogram. So we know that 1000 gram gives us 1 kilogram. So this will cancel this. If it goes here, so 430 divided by 430.228 divided by 1000. I'll be getting 0.43228 kilogram. So all I need to do now is to say molarity here is going to be kg of solution of, let's say, is water, minus kg of HCl, because what we need is the actual solvent. Notice that this is a this one is in, should I say, is in form of the solute, but it was mixed, and it's in liquid form, so they mixed up to get the solution. So if we want to get the actual solvent, kilogram of the solvent, we're supposed to subtract this. So by the time we now do, remember that this one is like a note. You just need to note this, how we got this. So by the time we now do molarity to be equals to 11.8 all over this, we've gotten this kilogram, all over 1.190 minus 0.430 equals to, let's do the maths. If we do 1.190 minus 0.430, we get 0.76. So if we do 11.8 divided by 0.76, we get 15.5263, which is approximately 16 m. So this is my final answer for molarity. So remember that the key to molarity is simply, in this kind of case where the two both the solute and the solvent are liquids, we must subtract the liquid, which is the solute liquid, from the actual solvent, so that we get the kilogram of the solvent. Then by the time we do mole of solute divided by the mole, the kilogram of the solvent, you see that we've gotten the molality. So you need to note that once you're given any question like this and you're given something of density, you need to go and convert this density to when it's in gram per liter and when it's in kilogram per liter, because you cannot solve molality with gram per liter but rather kilogram per liter. And when you're solving for mass of a particular compound or solution, and in chemistry you leave your answer in gram per liter, not in kilogram per liter. So remember how we converted this. We did 1.190 gram divided by 1000 gram. This and this will cancel out, and I'm in kilogram. So this one now is milliliter divided by milliliter again. So this and this should cancel out. You see that I'm left with 1.190 all over 1000 all over 1 all over 1000. So kilogram liter. So kilogram divided by liter. So you see that if this is kilogram and this is the liter, all I need to do in this case is to remember that, in this case all I need to do is to remember that everything liter is getting divided by everything kilogram. Everything kilogram is getting divided by everything liter. So notice that I have this is getting divided by this. I will use reciprocal law to do it, that this particular one, since it's getting divided by this particular one, this is 1.190 all over 1000, and this is divided by 1 over 1000 liter kilogram. So the only way I can now do this now is to remember, if I know that, I'll put it side to side. This becomes 1.190 all over 1000, then times, if I bring my times, so that this will now become 1000 over 1. This will cancel out, so I'm left with this. So that is for that. So the next question is to get the mole fraction, and we know that mole fraction is simply mole of solute all over total mole of solution. So let's check. There's a mole fraction of HCl. So mole fraction of HCl is simply going to be fraction of HCl is simply going to be equals to mole of HCl all over total mole of solution. which is equals to mole of HCl is the same thing as saying 11.8 all over, what is the mole of the solution? First of all, this is going to be 11.8 plus, let's get the mole of the solution. Have we gotten it before? Let's check if we've gotten it before. I don't think so, because yes, we know that the mass of the solution is okay. So let's find the mole of the solution. So mole of solution, remember that the solution is having mole of the solvent, sorry, let's call it the solution. Yes, the total of the solvent. Yes, each solute plus solvent makes a solution. So mole of the solvent, let's find the mole of the solvent. So remember that first of all, the solvent is having 0.76 gram. If you remember, we did solvent kilogram minus, that is kg solvent minus kg solute, and we got kg solution. Are you kidding me? kg solution minus kg solute, then we got kg solvent. Yes, because density talks about solution. So that means that mole of solvent is simply going to be mass of solvent all over molar mass of solvent. Now remember that the mass is in gram and not kilogram. So times this by 100. So 0.76 times 100 times 1000, sorry, because if you want to convert gram to kilogram, you divide by 1000, kilogram to gram you times by 1000. So this is going to be 760. So we moved it from 0.76 kilogram to gram. It's going to be times 1000. So we have 760 gram all over molar mass of the solvent, and we are taking it that the solvent generally is H2O. So that is 1, 2 plus 18 plus 16, which is equals to 2 plus 16, which is 760 all over 18, which is going to give me 760 divided by 18 is going to give me 42.2222, approximately 42 mole. So if I know this, I'll come and put it here. So that means that total mole of this is going to be 42. So that is 42 plus 11.8, which is the same thing as saying 11.8 divided by 53.8 equals to 11.8 divided by 53.8, which is equals to 0.2193, approximately 0.2. This is mole over mole. So the mole fraction is simply 0.2. That's my final answer. So 0.2. That's my mole fraction. Waiting. 0.2. Okay, that is my mole fraction for HCl. So if they ask me mole fraction of water. Them ask me mole fraction of water. It's simply going to be first of all, mole of water. Mole of water is 42.2, which is 42. All over total mole is 53.8. Total mole is 53.8 equals to, if I punch it, that is 42 divided by 53.8. I'm getting 0.7806, approximately 0.8. That's my mole fraction for H2O. Mole fraction for H2O. So thank you very much. So that's the 9 questions from chapter 2. All the 9 questions carefully solved.